Okay, for example number 2, it says let S denote the supply of hogs in Chicago and it's measured in thousands, and let P denote the price of pork in cents per pound. Okay, suppose that for S between 0 and 100, so for the supply of hogs between 0 and 100,000, the price changes linearly or proportionally with S. On April 1st, the supply is 50, okay, so we're looking at 50,000, and the price is 163 cents per pound. Okay. Now on April 3rd, a rise in S, okay, so an increase in the supply of 10, which is 10,000, leads to a decline in the price to 161 cents per pound. Okay, what happens if S falls to 30? Okay. Now, what we're going to do is we're going to set up an equation, but let me explain what's going on here. This is my field, economics, and so what we have in economics is we assume that we've got some relationship between quantity and price in a market, and we also assume that as the quantity supplied, or as the I shouldn't even say the quantity supplied, but we look at as the price changes, okay, what happens to the quantity, okay? So this is what we call the demand curve, okay? So as the amount increases, okay, or as the price drops, people demand more. As the price rises, people demand less. So we have this relationship. On the other side of the equation, we have the supply curve. And the supply curve usually shows this positive relationship between quantity and price, meaning the supply, the amount that producers are willing to supply to a system, increases as the price increases. Okay, so you got your supply and demand curve, and where they meet, this is called the market equilibrium, or the market clearing price and quantity. Okay, now we're going to set up an equation that represents what's going on up here. So what we need is the following. Okay, what I'm going to do is I'm going to let this be P is equal to some rate of change times S plus the B value, the intercept value. Okay, so this is like my Y and this is like my X. Now, how did I know that I'm going to put S over here and P over here? Well, I don't have to do it that way. I can rotate the terms. It's not that big of a deal. Okay, it's just that we're assuming probably that the supply changes the price, and so we're assuming that this supply amount, this quantity amount, is the thing impacting the price, not the other way around. So this is our independent variable, and this is dependent on the independent. Okay. So now let's go ahead and work through this guy. Okay. So here's what I know. Well, I know that M is got to be equal to the change in the price over the change in the supply. Okay, it's the change in the Y value over the change in the X value. So we can think about the equation as change in price over change in supply times supply plus the intercept value. This is the guy we got to find, and we got to know this guy right here. So they give us some data. They say that when S is 50, that the price is 163. They tell us that there's a linear relationship or a proportional relationship between P and S for values between 0 and 100 for S, and clearly 50 is between 0 and 100. Now, if we increase S by 10, so if there's a change in S by positive 10, so S equals 60, okay, so rise in S of 10, it leads to a decline. The change in P, well, P goes to 163. 163, excuse me, not 163, goes to 161. Okay, so our change in P is going to be equal to -2. Went from 50 to 60, a rise of 10, okay, and we have a decrease in price by 2. So our equation over here is P is equal to, the change in the price is -2, the change in the supply is 10, just like that. And we can reduce this to have P is equal to -1/5 times S plus B. Now the question is, what is B? So to solve for B, we can use either of these 2 points and plug it in here. So we've got, I'll just use this first one. So I got 163 is equal to -1/5 times S, which is 50, plus B. So that's 163 is equal to -10 plus B. So B is equal to 173. Okay, so that P is equal to -1/5 times S plus 173. Now we have to use that to calculate this. What happens if S falls to 30? So if S falls to 30, that's going to give us P is equal to -1/5 times 30 plus 173. Now 30 is still between 0 and 100, so we're good with this relationship. So I've got P is equal to negative, now 30 divided by 5 is 6, so -6 plus 173. So we have to subtract 6 off of 173, which gives me 167. And now this is in cents per pound, so we would probably just say that the price is going to fall to $1.67. Okay, so our cost, if our supply falls to 30,000, the price for your pork, okay, in cents per pound would be 167, so it's $1.67 per pound for the pork.